Okay, the next question that we got on the menu today is to evaluate the integral tan x dx. Okay, this should not be too bad, but the first thing that we want to mention is that tan x is equal to sine x divided by cos x. And in my opinion, it's going to be a little bit easier to deal with this integral if we do the conversion first. So if we do the integral of tan x dx, this is equal to the integral of sine x over cos x dx. Now, how are we going to handle this? We're gonna see that, hey, sine x and cos x, they're related because I know the derivative of sine is cos and the derivative of cos is negative sine. Okay, that's a nice thing to know. That kind of points me into the direction of using u substitution. Using u substitution, upon realizing that cos x and sine x are related through differentiation. Okay, so what should we set to u? In my opinion, it's going to be a little bit easier if we set the downstairs cos x to be u. And the reason why is because when we sub out the dx for du, the sine x is already going to be upstairs. So that's going to be a lot easier to deal with. So let's say that we have u is equal to cos x. We know that dx with respect to... my bad. The derivative of u with respect to x, du over dx, that's equal to, well, simply the derivative of cos x, which is negative sine x. Don't forget that negative. And if we want to isolate du, well, we can just multiply both sides by dx. So it's just du equals negative sine x dx. Okay, so you see that we have, I'll highlight this in green, we have sine x dx inside of here. So we can say that sine x dx is equal to negative du. Okay, and that's just to bring the negative to the other side because while these match, they're not a perfect match. We got to incorporate the negative into the du. Okay, so the next thing that we're going to do with the du is, well, let's just sub out everything in the equation. So I'll rewrite the original as sine x over cos x dx. We know that cos x is going to be u. So we have, on the downstairs of the fraction, we're going to have u. On the upstairs, well, it's just negative du. Because the sine dx that was previously on the upstairs is replaced by this. Negative du is equal to sine x dx, and sine x dx is what we're replacing. Okay, so this is actually fairly straightforward. So now this is really just the integral of 1 over u, which is... this is equal to negative. That negative on the upstairs of the fraction just gets kept. And then it's just 1 over u. The integral of that is natural logarithm of the absolute value of u plus c. Don't forget the plus c on your integrations. It will be painful if you do that. Okay, so now that we have this, we got to resub out u for what it is originally, which is cos x. So we can just rewrite this as negative natural logarithm of absolute value cos x plus c, plus the constant. And that could be our final answer. Now, as a quick check, if we wanted to do this, if we wanted to take the derivative of this, we should get tan x, or just sine x over cos x. So if we wanted to do the derivative of this, d over dx, well, this would be a chain rule situation, so the c would just be eliminated because that's just a numerical constant. It would be 1 over the inside of the ln x, so that's cos x, and the negative still up there. And then we have to multiply it by the derivative of what's inside the ln x, and that's just negative sine x. The negative from the negative sine x and the negative 1 out front, they neutralize each other to just be a positive, and then we just get sine x over cos x. That's tan. That's the same thing that we started off with. So we can give ourselves a big high five because that integral is solved. Awesome. So, and yeah, they came to same conclusion. Wait a minute. Wait a minute. Oh, I guess you could get rid of the negative if you send it up there, but you could perfectly reasonably leave it in here. Yeah, but you could change it to a secant if you move that the negative from the logarithm. You could put that as a inverse of the argument, and then it could be like just positive ln of the secant x. That's a valid answer too, but you don't need to necessarily do that. Okay, so yeah, the above solution is good.